In this video, I will explain the DC distributor, type of DC distributor. So distributor is nothing but it is a line or device which distribute the electrical power to the end consumer. Actually, we have two type of distribution. One is AC distribution, second one is DC distribution. In AC distribution, the distributor distributes the AC power to the end consumer, whereas in DC distributor, distributor is distribute the DC power to the end consumer. Then coming to the type of DC distributor. Okay, so based on based on the energization of a distributor, we can classify the distributor into four. One is distributor fed at one end, distributed fed at one end, distributed fed at both ends, distributed fed at center, and ring distributor. So this classification is based on the energization of distributor. Okay, distributed fed at one end, distributed fed at both end, distributed fed at center, and ring distributor. So we move into the distributed fed at one end. Distributed fed at one end. So you can see a figure 13.1. So in distributed fed at one end means we provide the electrical supply at one end of the distributor. Okay. So here AB is the distributor. So you can see AB is the distributor and we provide the supply. We energize the distributor by providing the supply at the point A. Okay. So that's why we are it named as distributed fed at one end. Okay, the energization or we provide supply at one end of the distributor at point A or point B. Okay, so in this figure we apply the voltage at point A. Okay, so AB is the distributor. Okay, and we provide a supply at one end of the distributor at point A, and we tapped off different current from the point C, D, E. Okay, so I1 be the current which coming from point C. I2 is the current which coming from the distributor point D. I3 is the current coming from the distributor point E. Okay, so the total current at A equal to I1 plus I2 plus I3. That is the total current in distributor A. I1 plus I2 plus I3. And what about the current at C? Current at C equal to I2 plus I3. Okay, current at CD. Okay, not C. Current at CD equal to I2 plus I3. And current at D equal to I3 only. Okay, so that is the current distribution in the distributed fed at one end. So the current in AC equal to I1 plus I2 plus I3. Current at CD I2 plus I3. Current at DE equal to I3. Okay, then coming to the voltage side, so the maximum voltage appear on the point A because we give the supply to the point A, and the voltage is decreasing when we move from point A to point B. So the minimum voltage appear on the distributor is at point B. The maximum voltage is occur at point A. So the voltage is decreasing from A to B. Okay, because we know that the voltage at A, that is VA is maximum. Okay, then the voltage at VC is less than VA. Why? Because VC equal to voltage at A minus voltage drop across AC. So some voltage drop occur along the length AC. So we minus that voltage drop and we get to the voltage at C. So I repeat, the voltage at C equal to voltage at A minus voltage drop over the section AC. Okay. Similarly, the voltage at D equal to voltage at C minus voltage drop along the section CD. VE, voltage at E equal to voltage at D minus voltage drop along the section DE. Then how you calculate the voltage drop across each session? Assume RAC be the voltage, resistance along the session AC. So what is the voltage drop along the AC? RA into, that is current into voltage, sorry, current into resistance, that is the voltage drop. Okay, so the voltage drop across AC equal to RA into I1 plus I2 plus I3, that is the voltage drop across AC. What is the voltage drop across CD? That is R, suppose RCD is the resistance along the CD. Okay, so voltage drop equal to I2 plus I3, current into RCD, resistance. Okay, then what is the voltage drop across DE? That is current into resistance. So current is I3 and let RDE, that is the resistance along the DE. So voltage drop along the DE equal to RDE into I3. Okay, so that is the distributed fed at one end. So here the thing is, when we move from A to B, the current is decreasing and voltage also decreasing. Okay, and one drawback is, suppose if a failure or fault occur on the supply side, so the total blackout happen on the system. Okay, so that is one drawback of distributed fed at one end. Next one, distributed fed at both ends. Okay, distributed fed at both ends. So here you can see that a distributor A, B, that is a distributor, and we feed the supply at the both endpoints. Okay, at both point A and point B. We supply the voltage at both A and point B. Okay, and in this distributor, C, D, E are the points from I1, I2, I3 are taken from these C, D, E points. Okay, so here the voltage, so the characteristics of voltage, when we move from A to B, the voltage is decreasing. From when we move from A to B, voltage is decreasing at a certain point. Okay, at a certain point in between A, B, so that point is known as minimum voltage point. Minimum voltage point. Okay, from that point to B, the voltage is increasing. Okay, so when we move from A to B, initially the voltage is decreasing at the minimum voltage point, and from where the voltage is increasing to the point B. Okay, so that is the voltage variation along the AB, distributor AB. And here, if suppose any fault occur on the feeding point at A, we can supply the whole distributor by giving the supply at point B. Okay, so that is distributed fed at both ends. Next one, distributed fed at center. Okay, distributed fed at center. So here AB is a distributor and we fed the supply at the midpoint of the distributor at C, point C. Okay, we provide the supply at midpoint of the distributor AB. Okay, so from C, there are two diversion or two direction. The current which flows to the direction A, and the next part of remaining part of the current which moves towards the point B. Okay, so here two tappings are here to the left side of the C point. Okay, one tapping that draws the current of I1, second tapping which draws from the I2. Okay, so total current towards the towards from C to A, that is I1 plus I2. Okay, similarly to the right side, total current is I3 plus I4 because two tappings are there in between C and B. One tapping which draws the current of I3, second tapping which draws the current of I4. So that is the distributed fed at center. Next one, ring mains. Okay, so ring mains. So in ring mains, we form a closed loop. Okay, we form a closed loop, and we fed supply at a point A. Okay, we provide a supply at point A, and from the other points from the ring, we tap the different current I1, I2, I3. So it is also a singly fed distributor. Okay, we provide a supply at a single point, and we take the output from the other different point B, C, D. That is a ring mains. Thank you.